Hello there. We're going to run through and mark the 9th of November 2010 paper in Unit 1. It's foundation level, and it's part of the AQA GCSE. In marking, I'm also going to hopefully give you some tips as to how you answer the questions and can get near enough full marks. Right, the table shows the weather in London each day for 40 days. Question 1A, complete the table. So what we do is we convert the tally marks to numbers. We put it in the frequency column. 2 lots of 5 is 10. Now, what did I say, 2 lots of 5? There's 4 tallies here, but when we get to 5, instead of adding another vertical tally, we put a horizontal bar across. So each of those represents 5, and it's quite easy then to convert it to numbers. Here, we've got 1, 2, 3 lots of 5, 15, add 3, 18. Here we've got 4. Here we've got a 5 again, plus 3, 8. And we'll just double check, does that add up to 40? 10, add 18, 28, 32, 40. So we picked up 2 marks there. Now, what fraction of the days are sunny? 10 days are sunny out of a total of 40. So the fraction that are sunny, the fraction is 10 out of 40. But it says here, give your answer in its simplest form. Now, it's a calculator paper, so let the calculator do the work. Let's just clear this. We type in 10, ABC 40. On the newer calculators, there'll be a button that has 2 rectangles separated by, well, it looks like this bit here. Okay, and when you see it on the screen, it'll have 10 directly over 40. And press execute, and there it is in its simplest form. 1 out of 4. Actually, to make sure that the examiner sees it, we'll put it here, so there's no confusion. So that's another 2 marks. Right, let's move on. Now, part C of question 1. In Manchester for the 40 days, so as opposed to London, 16 of the days are sunny, 50% of the days have rain, there is no snow. Complete the table for Manchester. So we put the 16 in. They didn't tell us how many days had rain, but they said it was 50%. So we get our calculator to do that. Yes, I know most of you know that 50% is the same as half. Let's just remind ourselves. 50% is 50 hundredths. The word of is times, and there were 40 days. There we have it. As I'm sure you worked out, it's 20. There is no snow, which is another way of saying there are no days on which it snowed, but we haven't fully completed it. It says the total is 40. We've only, the numbers in here only add up to 36. So we need to have 4 in here to make sure it adds up to 40. And there we have it, another 3 marks. Hopefully you've picked up near enough 100%. One of the days in Manchester is chosen at random. Use a suitable probability word. So they don't want a fraction or a decimal, they want a word to complete the sentences. The chance of choosing a day with snow is, well, there's 0 chances, so it's impossible. And the chance of choosing a day with rain is, well, there's 20 days on which it rained out of 40. So probability, if we were doing it as a number, is 20 over 40, which simplifies as a half. But it clearly said it wanted it as a word. And the word we use for where it's exactly 50-50, exactly half, is even. 1 mark for each of those. Right, let's go and move on now to question 2. Nick takes 4 tests. The pictogram shows his scores. 3 circles here for English, 2.5 for geography, and so forth. We're told that Nick scored 60% in English. Complete the key. 1 circle must represent, well, 3 circles represented 60. So 1 circle must represent 60 divided by 3. Double check that with the calculator if you're unsure. 20%. Which subject is its highest score? It's the one in which we have the most pictures. Circles in this case. And we've got 4.5 for maths. So, in which subject is the highest score? It's maths. Or mathematics. 1 mark. Jenny takes the same score, same 4 tests. The bar chart shows her scores. Draw a suitable diagram. Nick wants to compare scores with Jen's. Draw a suitable diagram he can use. Well, what we're going to do here is, when we're comparing two people's scores or such like, we have two similar diagrams. I'm going to use bar charts here. There is another way. We could have converted Jenny's to pictograms, but we're going to try and show a bar chart for Jenny's scores. Now you'll have to bear with me because I'm going to have to flip between page and page. Let's get our scale sorted out first. We've got 1, 2, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10%. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got to be quite meticulous here because this is where we're going to lose marks if we don't get the scale right. 1, 2, 3, 4, 5. Well, will I be able to get all on? I won't. That's all right. If, and I hope you have, worked in pencil, we'll do it this way. We'll have each 10 squares represent 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just check that that was the same scale as they used for Jen. It wasn't, was it? Oh, yes, it was. There you go, 10 to represent 20%. Okay, now, let's put our bars on. Oh, before we go any further, let's label percent. That's the score in the test. Also, we need a title. So we're now, remember what we're doing, we're trying to put all Nick's scores onto a bar chart. So it's Nick's possessive test scores. Right, what did Nick get? Let's do the first bar. Nick got 60 in English. So we flip back, and we're going to draw a bar to represent that. It doesn't have to start here, right at the left. I'm going to start 2 in, and he got 60. So that's how high it's going to be. And then we'll make it 5 squares across. Could have been more, could have been 10. In fact, if we flip back, we can tell how wide to make it. How wide did they make it for Jen? It was 5 squares. And that was his score for English. Now, what were his other scores? I think his other subject was geography. He got, well, our scale says that each of these circles represents 20. So we've got 20, add 20, and half of 20, so that's 50. So for geography, he got 50. So let's be consistent now. We're going to leave 5 and then go up. So 50. Now where would that be? Well, it's halfway between 40 and 50. Let's just double check. So it's going to be 5 squares. 1, 2, 3, 4, 5. It's going to be there. There we go. We got it right. Now the important thing is we make the bars the same width. So here we have geography. I'm going to use the abbreviation GEOG. Now his next score was that 90. Brilliant score in maths. So we're leaving a gap of 5. So we count 1, 2, 3, 4, 5. And we want to go all the way up to 90. Just double check, did I get that right? You'd use a ruler. Have I gone 5 squares up? 1, 2, 3, 4, 5. No, that's 5 squares up. So my bar's a little bit, this blue bar is just a little bit too high. And then we go 5 across. Oops, wrong line. I'm okay, this is electronic, so I can undo it. Not with the greatest ease. Let's just get rid of this blasted thing. Make sure it's on blue. And 5 across. It's important, as I say, we keep all those bars the same. And that was maths. And the final one, where was it? Was science. He only got 40% in that. So we'll leave a gap of 3, 5, and now we'll draw a final bar going up to 40. Five across. And there we go. And label it science. Now, to make sure that we pick up all the 4 marks, we put, well, what are all these things there? They're the subjects that he said, or just the subjects we'll do. So we've got a title for our horizontal scale and a title for our vertical axis as well. And that's how we pick up 4 marks. Now, question 2C, part 2. Write down 3 facts comparing their scores. Comparing their scores. Well, let's just be methodical here. What's the first subject? In English. That's the first one we looked at. Nick scored 60. And what did Jen score? And Jen scored 90. So the first thing we could compare them by, or compare them in, is how well they did in English. In English, Nick got less, I want to put in brackets, 60%, than Jen. What about in geography? In geography, what did Jen get? Jen got, bringing across, she got 70. And we know that Nick got, what did Nick get? And Nick got 50. So in geography, Nick got less, 50% than Jen. Just double check, I've forgotten. The old memory's going what Jen got in geography. Jen got 70. Than Jen, 70%. And finally, in maths, notice we don't capitalize the word maths. Nick got more than Jen, 90%. Actually, we don't need brackets here. I've worded it slightly different. 90% compared to. What did young Jen get? This is the problem about putting the values in. She got halfway between 40 and 50, which is 45. And for each of those, just pointing out which ones, in which subjects, who was better, we get 1 mark. Another way you could have answered this would be to say, comparing their strongest subjects. So Nick was, best subject was maths, whilst Jen's was English, and so on, and which one was the weakest, and so forth. So there were other ways of doing it. But I think this is the most straightforward and logical way, is to just look at each subject, each of the first 3 subjects, and then make a statement comparing how well they did. Right, we move on. Should be able to speed things up. It's probably, from my point of view, the lengthiest one to explain. A company makes bags of toffees. The company checks the bags contain 50 toffees. The number of toffees in the sample of 11 bags is. Write down the mode. The mode's the one that occurs the most. And our eyes tell us almost immediately that 51 occurs more than any other. So for that 1 marker. Work out the median. You must show you're working. Well, the first thing we've got to do is put them in order. Smallest to largest. So it's 43. You can cross these off in the exam. Was the next one up. 50. There were 2 50s. Let's make sure we don't miss out any. How many 51s were there? Well, we just worked that out. There was 4 of them. No, there wasn't. There's 5. You know, I've missed out a couple of 50s as well, haven't I? You always work in pencil. Or electronic pen. No, you won't. That won't help you much in the exam, will it? Actually, on a serious note, diagrams we do in pencil, but the working here should and must be in pen. So what you'd have to do if you made a mistake like I did is cross it all out and start again. Have I finished? No, I've still got to put 52 down. Right. Now, we've got to work out the median. Simplest way is this. Cross off the smallest, the largest, 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 and the one that's left is the median. Now, work out the mean. To work out the mean, we add them all up. Now, it's a calculator paper, so let's have a look. What have we got? Just move that over here so you can see. Now I'm going to, oh no, I'll put it back over here. I know how to do this. Close that. Right, let's add them up. So we've got 51, that was the first bit, plus. Now I've got a better idea. I'm going to add them up in order. That way I'm less likely to make a mistake. So it's 43 added to 50. Where's my 50 gone? Added to 50. Added to 50. Added to 50. Added to 51. 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 Added to 52. Now, I haven't a clue why that minus sign appeared there. Let's just get rid of that. And now, we press execute, and there's a total 550. Let's make that a bit bigger. No, that's better. So work out the mean. So the total is 550. You might have wanted to show all that addition, divided by the number of sweets that there were, 11. 550 divided by 11, so I'm sure you can work out, is 55. 3 marks if you got it. Now, if you didn't show any working and put down something other than 55, then you wouldn't get any marks. So do show all your working. In particular, this would get you 1 mark, and that would get you 1 mark, even if your final answer was wrong. Right. The company claims there are 50 toffees in a bag. Give a reason why this claim seems fair. And it would be because, on average, the mode average, there are 50. And that's using the mode as the average. You know, I got that wrong, didn't I? Well, now I'm getting a lot wrong. Just bear with me. Because actually the mode and the median and the mean weren't anything like 50. Yes, they were, because you know what I've done, silly me? 550 divided by 11 is 50. Right, sorry. Oh, he's gone to pieces now. Right, let's just get this all sorted out. Now let's word this better. Okay. Oh. Here we go. Why does this seem fair? Because the mean average is 50. Give a reason why this claim seems unfair. Well, there's 2 ways to write it. They say there are 50 toffees. Actually, on more occasions than not, there are. They said that there are 50 toffees. And actually, on more occasions, there are quite a few more than 50 toffees, probably 51 or more. But on some occasions, on one occasion in this instance, there was one that wasn't. So you could word it this way. on one occasion. There was 43. Or another way you could write it, well, an alternative way would be, well, actually, the median average is not 50, it's 51. So there's some alternatives there. 1 marks for each of those. Right, we move on. Not too much longer to go. The company uses the first 11 bags produced each Monday to check the contents. State 2 ways this method of sampling can be improved. Well, 11 bags. It's not very many, is it? So we could increase the number of bags sampled. What else is glaringly obviously wrong? It's the each Monday. Every on Monday, people are working at their maximum capacity, or the most conscientious. It may not be the same halfway through the week, and especially not on Friday. So, how can we improve our sampling? Take samples on other days. Take samples. Let's have a look. Take samples on every day. Perfectly good answer. Or take samples if you wanted to. Vary answer on let's have every other day. So on Monday, Wednesday, Friday. Anything really that shows that just choosing one day isn't the best way of sampling. Right, question 4 onwards. Work out 70% of 986. 2 marks here. We've got to show our working. So we do 70% times 986. So you've got a percentage button, or you could write 70 over 100 times 986. Clear that? So it's 70 over 100 times 986. There's the answer. Now, this calculator is given as an improper fraction. We'll change that to a decimal. So it'd be 690.2. There was an alternative way, wasn't there? We could have used, you may have come across this before, decimals. 70 over 100 is 0.70 or 0.7. Either of those times 986 would have given us the same answer. And for that, we gain 2 marks. Circle the calculations. So it's clear there's going to be more than one that have the same answer as 57% of 372. So let's have a look. First, we look for the most obvious ones. Here we go. 57 over 100. Remember, percent is just another way of writing a fraction over 100. Now, the others aren't so clear. They haven't got 372. And we're torn now between these 3. Well, there's the decimal equivalent of 57%, but 0.372 is not equivalent to 372. What about finding 5 points using the percentage button? 5.7% of 37.20 or 37.20. That would not give us the right answer. But this one here, where we're finding a tenth of what we want, but the amount we're finding it from is 10 times bigger. This also would give us the same answer. But how would you do it in the exam? If I was you, I would work out what, I would work out on my calculator 57%, so it's 57 over 100 times 372, convert it to a decimal, so it's 212.04. I would do that first, and then I'd work out what each of these came to. Right, so the 2 were 57 over 100 times 372, because 57% is 57 over 100. And here, because we're finding a tenth, the percentage that we're finding, 5.7%, is 57 divided by 10. But the amount we're finding it of, 3720, is 10 times bigger is 10 times bigger than the 372. So 1 mark for each of these. Right, we're getting there, don't worry. Freddie and Priya both like music. Freddie gives some songs a score out of 10. This diagram shows his results. What fraction of the songs is given full marks? Well, how many are given full marks? Just 2. How many songs were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 2 out of 13 were given full marks. How long is the song that has given a score of 4? Give your answer in meters and seconds. A score of 4. Ruling across, there is now ruling down. What do we find? Well, but if it was a decimal, we would write 5.4 minutes. But they want it in minutes and seconds, so it's going to be 5 minutes, 5 mins. And what's 0.4 of a minute? Well, the way we do that is, let's close that down, let's clear everything here. We do 0.4 of, remember as times, a minute is 60 seconds. And there we have it, 24 seconds. So the full answer is, minimize that, 5 minutes and 24 seconds. Oh, sorry, here's the space to put it in. So 1 mark for that, and 1 mark for each of these. Freddie has this hypothesis. The shorter the song, the more I like it. Comment on the hypothesis. The shorter the song, the more I like it. Well, let's look at the data then. If we were to draw a line of best fit, as the song got longer, the marks went down. That's looking at it from left to right. But looking at it from right to left, as the songs got shorter, the marks went up. So let's look again at this hypothesis. The shorter the song, the more I like it. Comment on this hypothesis. The scatter diagram supports, backs it up. Is hypothesis. Right, now, Priya also gives some songs a score out of 10. She has a different hypothesis. The longer the song, the more I like it. Her hypothesis is strongly supported by the data she collects. Plot points on the grid to show her scatter diagram may look. So remind ourselves again, the longer the song, the more I like it. So it's going to be going up from left to right. So we just have to put some crosses down here. But it also said it's strongly supported. So the correlation is going to be a strong positive one. So the strong positive means they form or are very close, all the points, to a straight line. 1 mark for that. A bag contains 3 red, 5 white, and 8 blue counters. What's probably of choosing a blue counter? We like these questions. There are 8 blue counters, so it's going to be 8 out of, there was a total of 8, 16. 3 add 5 add 8 is 16. So the answer is 8 out of 16. A different bag contains only black counters, pink counters, and white counters. 1 counter is chosen at random. Each color is equally likely. Write 2 possible values for the total number of counters in this bag. Only black counters. Each is equally likely. 2 possible values for the total number of counters in this bag. Well, let's have a look. You could have 2 black, 2 pink, 2 white. So one answer would be 6. Or you could have 3 black, 3 pink, 3 white, 9. Or, of course, you could have had 10 black, 10 pink, 10 white. in which case 30 would be an alternative. What you notice is that every single answer the examiner will have will be a multiple of 3. 2 marks for that. Now, another bag contains only green and yellow counters. There are more than 10 counters in the bag. When one counter is chosen at random, the probability of choosing a green counter is 3 out of 4. So if there was only 4 counters, it would be 3 green and 1 yellow. 3 out of a total of 4. But it says there's more than 10. So let's see how we can keep that ratio the same. We could have 6 green and 2 yellow. That's fine. Probably would be 6 out of 8. 6 green out of a total of 8. But that doesn't add up to 10. So let's treble them. We could have 9 green and 3 yellow. So the total number of counters would be 12. That's one possibility. Or, let's have a look. What other one could we have? We could, of course, have had 12 green and 4 yellow. 16. And, of course, there's other variations. We could have had 60 green, couldn't we? And 20 yellow. Or, more obviously still, 30 green and 10 yellow and so forth. This poster was put up in a school dining hall. Coming soon, new healthy eating menu. The head teacher thinks the number of students who eat school dinners will increase by 25%. Draw an observation sheet the head teacher can use to see if she is right. In primary schools, they tend to be she. Perhaps I needn't have said that. No, let's get rid of this darn thing. And an observation sheet. It's basically a tally chart, isn't it? Coming soon, new healthy eating menu. Who eat school dinners will increase. Well, how could you do it? Well, first we'd record the old menu. We'd see how many pupils ate dinner when it was the old menu. And then once the new menu came into place, we'd have a look and see how many ate dinner. You might want to improve it in reality by sort of like picking a particular time. But for the purposes of this exam, I think that's all they needed for 2 marks. The number of students who eat school dinners increases from 78 to 91. Is the head teacher correct? Show clearly how you decide. Well, let's have a look. So, 78 to 91 is an increase of 13. That's 91 take away 78. What's the increase as a fraction? It's 13 out of, you always go with the original, 78. What's that as a percentage? Because this teacher, head teacher, is thinking in percentage terms. We go back to the beginning. Remember, she said it would go up by 25%. So, we find out what 13 over 78 is as a percentage. So remind how you do it. So we would type it in as a fraction. So it's 13 out of 78. That's the fraction, and then you multiply the fraction by 100. And it's given us the answer as an improper fraction, which isn't necessarily a bad thing. We're going to convert that, though, to a decimal, and it's 16.6 recurring, or 16.7 to 1 decimal place. So is the head teacher correct? Now we make a statement in English. No, she is not correct. It rose 16.7%. She rose less than that, not 25%. Finally, I think on the penultimate page, Peter and Alice buy a set of golf clubs for their mother. They pay in the ratio of 4 to 3. Peter pays £224. How much does Alice pay? Well, let's have a look. Remember how we do ratios? Peter and Alice. So Peter's first person named, that's his shares. Alice with the second person named, that's her shares. Peter gets 224. So remember how we can do this with fractions. Alice gets information we want about Alice is this. The other bit of information with the same units, in this case shares, is 4. And what bit of information haven't we used? 224. If we put the pound sign in, we can get the units. So we do 3/4. I think it's because this video's taken so long. I'm getting bored now. Hang on, probably you are as well. So it's 3/4 times 224. She gets £168. At the school fair, I play a game 20 times. Each game costs 50p. Each time I win, I receive £1.50, probably winning as 1/5. How much money do I expect to lose? Well, let's have a look. The cost of playing 20 times equals 20 times 50p equal to 1,000p, or £10. Expected wins. You expect to win 1/5 of the time. What's 1/5 of 20? Oops. So you do 1/5. The word of is times 20. So you expect to win 4 times. And expected amount you win is the 4 times you just calculated times the prize, which is £1.50, equal to £6. So you expect to pay £10 and expect to win £6. So how much money do you expect to lose? It's going to be the cost, take away the expected winnings, and the answer would be £4 for 3 marks. You might pick up 1 mark here for showing the £10, the cost of it. Almost definitely 1 mark for the 4 times. And if 6 was seen, possibly 1, maybe even 2. Right, and that's that. I'm sure you're relieved to hear.